Hello, everyone. If you're late or you're not sure where you are, so just to make sure, you're at the Build an AI document inquiry chat with offline and LLMs. Anyone not in the right place? Cool. Most of you were here before, but if you have just arrived, there is a few instructions to get started. There is a little bit of infrastructure limit, and we're way over that infrastructure. If you do not have access, please make sure to sit down by a colleague and work together. This is a workshop for us to learn. So sit in pairs, do not just stare, but be proactive on that. And with you, Pavithra and Philip.
Thank you. All right, so I think we're at limit, right? We have 50 spun up, so I still don't see folks pairing up, but please do and follow along. Okay, so yeah, I'm Pavithra. I work as a developer advocate at Quansight, and
I'm Philip. I'm a senior software engineer here and the lead developer of a tool that we're going to use later on in this tutorial.
Okay, just a quick side note, because, I mean, just so we know and we can speak the same language. So the platform that we are running this tutorial on is called Nibari. It is a customized Jupyter Hub. And the only thing special it has is you all have access to GPUs, folks who are using this right now. And the environment that has all the all the packages and libraries we'll need, it should be auto-selected. Otherwise, it is the global PyCon DE. So you should be able to select your kernel in a notebook, right? And you can select this one in case it's not at any point. All right, so that's the only thing you need to know. And yeah, we can get started with the tutorial. Do you want to go? Just some goals, I guess. We'll follow this rough outline. So we'll start by running a local LLM first. I'll let you show them which one it is. Yeah. OK. Yeah, then we'll introduce RAG. Folks who are not familiar, again, we'll go to that. It's a way to improve the accuracy of LLMs. Then we'll use the local LLM with RAG and Ragna. And finally, we will put this all together in a UI. And you should be able to just explore and experiment with it. So that's the current flow. So handing it over to Philip for the first.
Yeah. Just real quick, since we are two speakers, if you have questions in the middle of the talk, just feel free to just raise your hand. One of us is always running around and try to help you. Of course, we're still just a single person, so if 5 people at the same time do that, you just have to wait a little. OK, so the notebook you're currently seeing is the one marked as 00, and then we can switch to the, oops. That was not intended. Oh, it worked. OK. So I know LLMs have been the craze for the past year and a half, I guess. But just for the off chance that someone doesn't know what an LLM is or a language model is in itself, I'm just going to give a rough outline. So a language model in itself is just a model that, given an input, predicts the next output. So you can imagine it basically as the autofill on your phone. If you have typed a certain amount of characters, it just it guesses what the next characters or the next words will be. And a language model is doing exactly that. If you put another L in front of it, so a large language model, these are the models based on this transformer architecture. This is basically where all the tools that you may or may not have heard about in the past 1.5 years, like ChatGPT or the underlying LLM, it's called GPT-4 currently. There are so many more. This is the actual language model that is driving these tasks. But yeah, so in general, the language model in itself is just a very, very fancy way to autocomplete text for you. So just when you see these models online, and if you actually look into one, so we're going to use one here in a second. There's one thing that you usually also want to have. It's called instruct tuning. So if you ever look into LLMs, running them locally, you often find ones that are marked with instruct. This is basically just these LLMs trained after they have been trained to auto-generate this text, they have been trained to actually answer questions for you. So all the LLMs that you will see in the wild that are able to answer questions, they are all instruct-tuned. Basically just a fine-tune after the initial train on, yeah, let's call them questions. Like you give a question and the LLM gives you an answer. Okay, so the ones that you, or like most people are comfortable using are the ones hosted by a large company, be it OpenAI, be it Anthropic, be it, there are so many more providers out there. But this has some implications for you. You basically, if you develop your application just with OpenAI, then you're locked into this vendor. You have the whole problem of data security or privacy in general. Like if you want to use an LLM for your task and you need to send all the data to OpenAI, you better make sure that you're even allowed to do it. And yeah, you're not losing any kind of company secrets or whatever on the way out. And so these LLMs in general, they are, of course, these companies have their own variants from it, but like in general, they are not like magic. They're just language models that you can run yourself as well. And this is when we call it local or offline LLM. This is, we're just going to take openly available weights, load them, and run an LLM on a GPU instance for you guys. And the one that we are going to use for this tutorial is Llama 3. So Llama 3 was released last week, so it was kind of nice for us to include it in the talk. We could have used a different one, like the talk was originally planned for Mistral, if that says something for you guys. But we're going for Llama 3 because so far it has been breaking a lot of benchmarks, and it's available on a permissive license. So if you want to use this commercially, I think you can, unless you have more than like 700,000 users a year or something like that. So do read the license in detail if you want to use this commercially, but for this talk we are certainly covered. If you go into running these models locally, you will very soon run into something that's called quantization. And like the whole thing that is behind that is usually when these LLMs are trained, they are trained with floating point numbers, either float 32, which is the most common, but sometimes also float 16. And the number that I've just mentioned, float 32 or float 16, is the number of bits that you have per single value. And a problem with that is that these models are really, really large. So if you look into, like, for example, how Llama 3 was trained, it was trained in a data center of 25,000 GPUs, which each GPU having like 80 gigabytes of VRAM. Like, unless you're Meta, you're not going to have this kind of infrastructure. So inference is, of course, much cheaper, but you still need to load the weights inside your GPU to even be able to run it. And so just to have like a rule of thumb, if you see like a model that says, hey, I have 8 billion parameters, or in any number of billion parameters, you need, in this original representation, you need roughly like 4 gigabytes of VRAM per billion parameters. So for example, if you use the smallest version of this Llama 3 series, the 8 billion parameter model, in its original float 32 representation, we would need 32 gigabytes of VRAM. And that is already exceeding most of the consumer GPUs available. So yeah, you can chain it, but like even then, 32 limit is already pushing it. And we didn't even have like the input itself, like if you want to process a prompt and so on, this also takes VRAM. So this is usually, yeah, it's done for the actual training, but after the inference, you do a technique, it's called quantization. What quantization does is basically it takes the float 32 representation, so floating point number, and breaks it down into a fixed number of levels. So you can imagine it just going from floating point to integer. And with that, we can drastically reduce the amount of memory that we actually need to load. And so just given the other rule of thumb here is we have roughly n times 8 gigabytes of VRAM for each billion of parameters, where n is the number of bits that we used for our quantization. And so depending on how much VRAM you actually have available, you can select like a number. Like just to give some rough estimates, like 8 bits per weight is almost equal with the float 32. So that is fine if you actually have like 256 levels for each floating point number. 6 seems to be currently the sweet spot. So this is something like between 6 and 4 is where all of the models perform really well for the amount of gain that you get from quantization. And so for this tutorial, we are going to use 6 bits per weight. And for that, for our 8 billion parameter model, we only need 6 GB to load it in. That should fit in most consumer GPUs, or let's call it reasonable current consumer GPUs, and it's going to fit in the one that we currently also have provided for you. Okay, so if you have quantization, there are like a number of different techniques and a number of different libraries to load all of these. They are, let's call it roughly equal in the terms of usability. We don't have time in this tutorial to go in actual comparison between these different quantization schemes and different libraries, so we just picked one. The one that we use is XLlama 2 or XLlama v2. Currently, from the benchmarks that we have seen online, this is the one that gives you the best inference speed, best. I'll just let it stand in that way. Oh look, we made a typo. It's not Mistral, it's Llama 3. So you see, I'm not lying. We actually planned this for Mistral 7 billion. Okay. Yeah, and from that on, if you have a GPU available, and you should be able to have one right now, you can actually start in running these cells. So if we import all of this stuff, don't worry, the import actually takes quite some time. The important part, or like the expensive part here is Torch. If you know, like Torch, this is like a 2.5 gigabyte dependency. So if you import it, that takes some time to load all of this stuff. And from there on, we have very few things to do. So the first thing that we do is we need to provide this XLlama 2 library with a model that we're going to use. And we have selected one for you. You see, like in this name, you have the Llama 3 8 billion. Then we have this instruct tag that I talked about. Like this is like an instruct tuned version that we can use to answer question. And then you have this EXL2, which is the quantization format that XLlama v2 uses. Yeah, like there are more. I've listed them here. You often will see something like GTPQ, GGUF, AVQ. They're like AWQ. There's like a lot of formats, but the one, if you want to try this with different models later on, the one that you are looking for is XL2. So we have these models downloaded in this shared directory for you all. Like I said, this is roughly 6 gigabytes, so you don't want to download them now on the connection of this of the conference because we're going to overload it. Yeah, and then this here is a lot of boilerplate where you set stuff up. Sure, we have to do it, but it's just basically setting up like, okay, there's this model, prepare to load it into the GPU. How are we going to cache? How are we going to tokenize? So, do people know what tokenization is? Okay, see a lot of nods. Someone not familiar with what tokenization is? Yeah? Okay, at least one. Okay, then let me just give a quick explanation. So if you want to use a language model, be it a regular language model or a large language model, at some point you will have to translate text into math, because these models only do math, they don't do text. And so tokenization is, tokenization is a way, no. What am I talking about? I'm sorry. I was at embeddings. Sorry. Yeah. So like, if you take there's a question. If you take like a sentence, sorry, that was wrong. If you take a sentence and you need to tell, like, the model internally works on tokens, not on words. So token is basically, like, let's call it like an index for a specific sequence of characters that is used internally to even present these sequence of characters. And tokenization is basically the step going from text that you have into these integer numbers. So every single LLM out there basically has their own dictionary to do that, or like uses a different tokenizer. This is why you load the tokenizer together with the config for your model to have the right vocabulary that your model understands. Okay, so the next step is we can load a generator. This is the actual thing that is going to do the generation for us. And then we have a lot of settings here to do that. So the important ones are. Yeah, okay. Sorry if you guys, because we had the question, if you're running into problems with the VRAM, that's the VRAM is overflowing, you will need to restart your kernel, because the problem is, if you load this and you leave your kernel running, the kernel that is running is hogging 6 gigabytes of VRAM. If you do this 3 times for 3 notebooks, then our 16 gigabyte GPU will no longer be sufficient to just load the weights. So there is at the very end, there is a note in here. Just stop your kernel if you're done with a notebook to basically kill the memory that this kernel is hogging for the model that you just started. Okay, I was talking about the configuration settings. You have a lot of settings here. Internally, what happens is instead of just generating one next token or predicting one next token, the LLM actually predicts multiple ones, and then you have gives them a probability that these tokens should be the next. And you can select how it actually gives you back tokens. And so the temperature, the top K, top P, and this token repetition penalty, they are ways to influence how the LLM samples these. So if you, for example, set the temperature to 0.0, this means it will always take the one with the highest chance. This is good if you want to have determinism. But if you want to have creative writing, you probably want to have it generate a few more and let's not call it random, but a little bit more variety. And so these are the parameters that you can tune to do that. We're just going to show them here for a question answering context that we're going to move to fairly soon. We probably want to have determinism, so you will see in the later configurations that we use, we're just going to set the temperature to 0.0 to get determinism and just completely ignore the other parameters. So this basically means we have no sampling there. Okay, and so now that we have that, we can actually start and generate something. So this is just taken from the inference script of the XLlama 2 library, and so you just give it a prompt. In our case, our story begins at PyCon DE where once, and we just ask it to generate at maximum 150 new tokens. And so if we do that now, we are going to wait a little, and it gives us an output. I'm not going to read it. Everyone that has a GPU instance available can generate their own stuff. But you see, for creative writing, this stuff is actually doing a decent job on generating a response. And then one thing that is also very common and is a lot better for the usability is you saw we just waited around 4 seconds for any text to appear, although the actual process is inherently sequential. So you always generate one token at a time. And so there's no need for us to wait for such a long time to actually generate an answer. We can actually stream it. Streaming is a little bit more involved. Well, not more involved. It takes more boilerplate to do it, but it is not really more hard than it was before. So we can try the exactly the same prompt, and this time we're just using a streaming generator rather than the base generator that we saw before. We're starting our stream. We are taking one token at a time. You see we're looping basically here over these max tokens, and we're going to break early if we hit the end of it. So if you do that, you will now see we get output directly when we execute the cell. And since we had selected a few variables on top to actually do some random sampling, you will see in general the idea is the same. It conveys the same message, but since we have some sampling, it will not be word by word and will not be it will not be exactly the same. Cool. So that is. Yes. So there was a question like, how do you select the tokenizer? So the tokenizer is very much bound to the model that you are using. So each model, maybe we can do like a quick tour here. So if you want to go into the actual weights that you saw, like we are in this directory here. We are in the llama 3 8 billion instruct XL2. And if you go in there, you will see at some point there's a tokenizer.json and there's a tokenizer config.json. If you go into them, you will see the parameters and the vocabulary that this specific LLM is using. Sometimes, like there are multiple LLMs. If you have like a family, for example, like if you have like the Llama 3 family, they will all use the same tokenizer or the same vocabulary. But in general, you should not expect that two models should have the same tokenizer. Usually, they just come with a tokenizer for each model, and this is why you configure them in a way like you just take this file and create a tokenizer from it. Like, there's no real, let's call it standardization yet. There's no fixed format, but this is kind of the format that the community has agreed on. And so all the common libraries should be able to support it.
There's like a couple more levels of zero. It's not visible.
Oh, yeah, sure. That's the wrong. That was. So can you give me a thumbs up when it's large enough? I see one thumbs up, some thumbs down.
Let's close this one.
There is a thumbs down at the end, so let me just increase more. Better now. Okay, so I hope I can get everything on screen. Cool. Yeah, so this was it for the local LLM. So you already know now how to run a local LLM. Do we have for this one here a little more? Yeah. Yeah. Yeah, let me just show you real quick where you can download these weights actually. Like we did it for you because this is like a 6 GB download and we don't want to do want everyone to download this now.
There should be a link. Okay. You go up. There should be a site how to do this yourself.
Yeah.
There's an X2 and Hugging Face.
Yeah, exactly. Sorry. Sorry, we have the.
I think it's just a tab to click actually.
Click. So I wanted to go there. I'm sorry.
Oh,
so I can.
Let's just remove it from.
Sorry, not my laptop.
Come on, Josh.
Yes, please. I'm sorry. Okay, so Hugging Face. This is like if you are familiar, at least somewhat familiar in this LLM space. Hugging Face is the central hub to share weights, and on there you can find basically. Just go to Hugging Face. Like there's a .co. Probably there should be .com. If you are on the Hugging Face hub, you can basically search for weights. In our case, it would be Llama 3. And
Internet is slow.
The internet is slow. Yeah, okay. Well, I'm just saying, like, there is an M missing, probably.
Yeah.
Oh, Hugging Face. Oh, perfect. It's perfect timing for this tutorial that they are done. Okay. So at least it's not our fault. Yeah, okay. We can try again at the end. But basically what you're...
It's working.
It is working? Okay. Well... We have like differing opinions. Okay, so there's a search bar on Hugging Face Hub. You could basically put in the model name that you want, for example, Llama 3, and then you will see like a bunch of people that have taken the original weights, so the original weights published by Meta, and have quantized them. And so some people have a fine-tuning on them, and sometimes you see like an extra tag called biomedical, or like there's like different spins on these original weights. And the way you do it is basically you just clone the Git repository, which has like these large files in it stored in like Git LFS. And then you can just point your library, this xllama2 here, to this folder that you just cloned, and you should be good to go. Again, if you use a different quantization scheme, you will need to use a different library. Each quantization scheme has some ups and downs, has a different library to use. If you want to stick to the slides that we have, just go with the XL2 weights. Okay, any questions so far before we move on into like making?
And tokenization. So should for different quantization choose different tokenizer?
No, so the tokenization is bound to the actual model architecture. So like if you have Llama 3, it will always have a Llama 3 8 billion. Let's like make it concrete. You will always have the same tokenizer. Quantization just changes, like it's called the math inside library, but it doesn't change how how the model understands the language in a sense. Like it doesn't change how the tokens are used. I don't see any other questions. There is one. Yeah.
Does Meta publish how deep the neural network is that you're using? Because basically you're using a fixed system, right?
Yeah.
And so they have decided originally how big and wide that neural
Yes.
network is.
Exactly.
Do you know how? Is it part of the sort of attribute of?
Yes. Like if we talk about these weights, go there again. At some point you have this large file which is called output.safe tensors. This is actually holding like 6 gigabytes of weights, and you need to have like an exact plan how these weights are arranged to get the exact behavior back. So the model architecture for of course for these open source or for these open models is always known. For models like GPT-4 or Claude from Anthropic or something like that, it's guessed. Like there's a lot of chatter and a lot of people have opinions on how it looks like, but this is more company secret, so we don't know exactly. Most providers, they publish like we have used so and so many parameters, or we have used like multiple experts that gets pooled, stuff like that, but you don't really get like an answer on how this stuff works exactly. Well, it's their company secret, so you shouldn't expect to. But like for the open ones, it's always 100% known how this works. Otherwise, you won't be able to run it. More questions? Yes.
Is Llama one of the models where you know exactly how the tensor structure
Yes.
will be like?
Yes. So like I said, everything that you are able to run and download from Hugging Face, this is exactly known. Yes.
So sorry, another quantization question.
Yeah.
So do you lose information by doing that? And
Absolutely.
does basically, do you have to, when choosing a method of quantization, do you need to take into account how you want to use that model, or how is it done?
Well, usually, to answer the first question, yes, you absolutely lose information. The question is then, like, how much information do you actually have encoded in the float32 representation in the first place? Like I said, with 8 bits per weight, you can always almost match the float32 performance, meaning you don't have more than 8 bits of information encoded in the number in the first place. Of course, you will never match the exact, but it's just as close as you get to the actual number, the better you will be. Like I said, 8, it's already like a factor down of 4, just in the bits. Of course, it's internally it's a little bit different, but yeah, you lose information. But like I said, between 4 and 8, there is a sweet spot where it's.
So you would look at model metrics and then compare
Yeah,
how much you afford to lose.
Exactly. Like the way it usually is presented is you have a graph where it says, okay, if I use whatever 3 bits per weight, which is really, really low, using a metric, and I compare the original weights against my quantized weights, how much performance drop do I have? And you will see that for 6 bits per weight and above, these two lines are basically a match. They will not be the same, but and yeah, you can of course check for the use case that you have. The way that I've seen it most is just use as many bits per weight as you can use that your GPU will hold. So you do a rough calculation. For our case, we have a 16 gigabytes of VRAM available in GPUs that we provided, and then you can say, okay, I can fit with 8 bits per weight, I can fit 8 gigabytes in there. I can use this and still have 8 gigabytes left for the prompt and the actual work that the GPU is doing. So you should be. But if you use larger models, this is a lot more an interesting question where it's okay, I have to have this trade-off between how much context can I actually put into my GPU, and how many bits per weight can I use? And this is then, this is where you need to trade off. For these small models, it's usually just use as much as you can. Yeah?
If I want to train on specific type of data, like biochemistry, right?
Yeah.
Can I use a tokenizer to tweak the way that it doesn't tokenize certain specific words in biochemistry, but it does tokenize other words? In other words, can you basically adjust the data that is being used to effectively?
Well, the tokenizer is just used basically to translate your string into like IDs that the LLM uses. If you change the tokenizer in a sense to drop words, then you're just basically leaving out information for the LLM. The question is like, there's probably no need to do this on a tokenization level. You could probably do it before if you say, okay, I don't want to use this. The way it usually works, if you want to have like a more biomedical context, for example, what happens is if you have the original weights, they're trained on an absolutely massive corpus of data, and it just is like a very generic data. It's just all kinds of language. If you want to have this give it more like a biomedical spin, you then take like a biomedical corpus and just fine-tune these weights on this. So basically, to change the probability, if I say this word in a biomedical context, the next word will most likely be this rather than some other word that it is in a generic context. So this is what you will see if you have this extra tag on Hugging Face. It's called biomedical or whatever you have on there. So this is usually then fine-tuned on a specific corpus for a specific use case. It's not going to say that it's not going to work on other use cases, but it's just then going to, well, I'm calling it prefer completing this biomedical context. Yes?
So you want to talk about RAG, right? So
yes.
You mentioned about these tags for domain-specific, for example, biomedical.
Yeah.
How do you compare going for a RAG for a known knowledge base versus these tags? So what are the pros and cons? I mean, of course, the RAG comes with only the known sources, and tagging maybe it is fine-tuned with larger or unknown sources. So
okay.
How do we choose when it comes to should I go for a fine-tune for biomedical or do you go for a RAG?
So this is, we're going to talk about RAG in a second, just to give you like the generic answer for how LLMs work. You have the actual weights, which encode something like, let's call it long-term memory. This is something that the LLM has learned, but it's something that it's very easily tries to hallucinate on. Like imagine yourself like you getting an answer for something that you have learned like 30 years ago and haven't used since. You probably will find the right things, but it's very easy to hallucinate stuff around that. So fine-tuning is usually there to make it easier for the model to get the language right. So to get like, okay, if I have this term, it's probably this term next, but it's not really a good strategy to encode like actual knowledge. You don't want to train it on your corpus and then just ask it about questions about this context. What you do then is actually, instead of just asking a question, you give the model more information to reason about, saying like, okay, here are X documents, please give me an answer on these documents. And I think this is a very good bridge to our next notebook. If no one has a question, I would just move over there and then I explain what RAG is, and it's exactly for this use case you just mentioned. Cool, and go.
Okay, and I will remind you to just stop the kernel on this notebook and close it before we move on to the next one. Let's go to... Okay, so just to get like a read of the room, how many of you have heard of RAG or used it before? Okay, so this section is going to be pretty much useless. Well, I guess for folks who are not familiar, RAG is a different way, like I think Philip just explained, how fine-tuning is also a way to improve the accuracy of LLMs, but RAG is a way where you can provide documents and context to the LLM, and then ask questions and get answers about those. So just, I guess, to illustrate why this is needed, this is ChatGPT, and we asked, what is PyCon DE, which it was, I think, trained on, because PyCon DE has been around for 10 years, as we heard today. However, it did not know when was PyCon DE 2024, but it's clearly not September 23rd today. So what we can do is use RAG, right? And we'll see if we can do better. So an illustration of how RAG works, like the technique. So the user, we have two things to do. First, provide context, relevant documents, and two, the actual prompt, right, to the LLM. So what happens is both the documents, first the documents are tokenized, and a vector embedding is created and put it in a source storage. So in Ragna, actually, we use the source storage vocabulary. It's a vector database for, that's a term you'll be more familiar with. And the same thing happens with the chat, right? And so with the chat, with the query that you have about these documents. However, once the query is also tokenized and an embedding is created, the relevant chunks of your document that are related to the query are pulled out and provided to the LLM. So the relevant chunks are taken, they're passed to the LLM, and the LLM also, of course, receives your question as well. So ideally, if this works correctly, you have a more accurate answer that was based on the documents that you just shared. All right, so is that clear for folks who are not familiar with RAG? We can move on, all right? So that is RAG. Next, what is Ragna? So this is the this is the tool that Philip created. So Ragna is a RAG orchestrator where you can use different LLMs and source storages, so you're not bound by them, right? And Ragna comes with a REST API, Python API, and a web UI. So it lets you use all of these, and within Ragna, what you have is a scalable task queue. So you get to play around with these through, for today, and for today's tutorial, we'll be using the Python API. So using that with any LLM out there. So we'll use both OpenAI's GPT, as well as Llama 3. To build things. And today we'll be building a chat interface, chat prompt. Okay, so any questions about orchestration? So the second half of this is just the other things you can do. So the UI, as we said, is not in Ragna, right? So Ragna has the Python API and the REST API. The web UI is something you can build with the REST API. Similarly with the IDEs, today we'll be using Jupyter Notebook as the IDE to connect to the LLMs and the vector storage, right? So any questions here? Yeah.
If you have this document storage, when you ask a question in the chat, how does it determine which documents are relevant?
How does it determine which documents are relevant? I think that's where the example here was similarity search, but do you have a specific one?
It depends how deep the question wants to go. Like, the question you're asking is about the vector databases. Or you put in a question, you want to know which are the relevant chunks, right? Which are the relevant parts of the documents that I have stored before to pull for this. I'm just going to give you the answer for vector databases. There are millions of techniques out there to do this, but the ones that you will find the most in the context of RAG is called vector databases. A vector database, like the name implies, it stores vectors, and instead of doing an exact search, searching for I have this vector, give me this exact vector. It's I have this vector, please give me 10 that are most closely related to this vector. And so if you have, this is what I wanted to say earlier, but I mistreated for a tokenization. Embedding is the way that you go from text to a vector. So it's you have a text and you want to represent this as numbers, because in numbers you can fairly easily resolve something as how much or how closely is this vector related to a different vector. We have tons of metrics out there. If you use L2, if you use cosine similarity, there are tons of metrics to do that. but you need to have like an embedding model first. You basically take the text, you embed it into a vector, you store all your documents in chunks into this vector database, and at runtime, you take your prompt, embed this as well, go to the vector database and say, hey, give me the 10 closely related vectors to this. And depending on how good your embedding model is, and depending on how good your questions phrased, basically, this will turn up more like good or bad sources for this for this process. Like, yeah. Does it answer? Yeah.
Okay. Okay, then I guess we can get started with just first steps of Ragna. So we'll be using GPT-4 for this notebook, right? And you need API keys from OpenAI to use GPT-4. So we have shared, like folks who are on Nebari will have access to a key. But for this notebook actually can be run locally if you want, right? So what you'll need to do is get a key from OpenAI. So there's a link in the material, and export it on your terminal before you start Ragna. So, and yeah, you should have access to GPT-4 then. Does that make sense? Okay. So for now, we'll just load the key from .env. Okay. And okay, so for documents, because the initial questions were about PyCon DE, we decided to share both the FAQ page and the PyLadies pages. This is just the website pages actually downloaded as PDFs and shared. Okay, but if you are curious, there are more files available in. Oh my God, come on. Yeah, there are more files available that you can add to this if you want to ask questions. Yeah. Yes.
But before the notebook before we were using
yes.
preparing for the local
yeah.
using Java.
Yes.
And we cannot obviously we cannot use GPT-4 locally because we don't
yeah.
have the weights.
That is true. Yes. So we did want to share both. So this, to be clear, this notebook is only going to use GPT-4. Yes, in the previous notebook, we used a local LLM. In the next notebook, we'll use a local LLM with Ragna. Got it? So this is just to keep the Ragna syntax simple. That's why we are not using the local LLM in this notebook and introducing Ragna first, okay? All right, so we will use those documents and select assistants. So in Ragna's vocabulary, we use assistants for LLMs and source storages for vector databases. Because we shared the OpenAI API key, we will have GPT-4 and GPT 3.5. Just importing those. These are shipped with Ragna, so Ragna has support for these, and several other assistants, which you can actually take a look at in the docs. You'll just need keys from all of these. These are vendors, right? So you need keys, API keys, and then you should be able to access them. Okay, so going back. And for source storages, currently Ragna has support for Chroma and LansDB. Okay, so the first step is we create a RAG instance. And we do rag.chat, where we provide documents, the source storage, and assistant we want to use. So for this particular chat, we are using Chroma and GPT-4. And then Ragna is async by design. So there's always a prepare step before you ask questions so that things can start running. And sometimes this takes a while when we have documents and like large documents. So to create the embedding and things, that will start automatically once you start executing this. So the current documents are fairly small, but if you have something like 50 gigs, it's going to take a while. Okay, so that should be it. And now we can ask the same question, and let's see what answer we get. Okay, yeah, that's correct, I think. And next is, yep.
Just one question about the ingestion pipeline of the PDF documents.
Mm-hmm.
It's usually like the magic. How is it done in Ragna?
We don't have any special source over the other.
So mute PDF or something, taking the text there.
What the like Pavithra already has showed it. Like you have the ability to put in any kind of source storage or vector database and any kind of processing pipeline in there. So this is up to you to choose. But yeah, like from all the built-in stuff, we don't have anything over the other vendors as well. What we've seen in projects that we did so far is everyone had their own way of doing stuff and parsing their own documents, and every document or every document type has their own special requirements. So it's really, really hard to find something that is works well in general. So we are providing like the basics to provide or to parse basic PDFs, and like I said, this is not special for Ragna over any of the other tools. But what is special in a sense is you can, strip in or you put in your own pipelines that you want to use, and still use the same API, use the same UI, and we will see in a second.
And I think that's the hard engineering part of knowing how to process things. You can see that, for example, Llama Index, that's how they monetize their product now.
Yeah.
By providing a PDF reader in the end.
Yeah, and I mean, that point I can probably do 30 seconds of promotion. Like, we come from company Quansight, and we offer like consulting services around that. So if you have the need for a RAG pipeline and you want to have the knowledge and want to deploy it yourself, then this is something that you can speak to us about, and we can hook you up with that. But like I said, the whole project in itself is fully open source. You can do it yourself. If you don't have the knowledge and you want to have help with that, we are here to help. Okay, that was a different question?
Yeah, would you say is there a difference between parsing the documents as PDF or as plain text?
Yes, like if you try to parse PDFs and you have actually looked into what you get out, it's actually really hard to get, let's call it, relevant information out of a PDF. So yes, you will of course get all the text, but you will always get a lot of extra tokens or like extra signs that were put in there. So I would say, like, if you can create a tool where I give you like a PDF, like a randomly formatted PDF, whatever it is look like, and you can actually just extract the text, you can be the next big thing in this whole AI. For real, like you will get a lot of money if you can invent such a tool. But like this also shows you like how complicated this actually is. Like for all the projects that we've done, it's usually very much driven for this specific use case on how you actually extract the data. So you try to find some kind of similarity between the documents. For example, if you always have like, let's call it medical documents, or you have all your documents are formatted in the same way, then you can say, okay, I often see this phrase. For example, if you have a lot of letters, you can just try to remove all the letterheads from it, because that is stuff that is also gets pulled out if you just pull out all of the text out of a PDF. But like I can't just build like a remove letterhead PDF extractor into Ragna, because each letterhead is going to be different, and so like the previous commenter already said, this is the really hard part when working with data. Yes, over there's a question. Sorry, I don't want to take this over.
How's your experience working with tabular data, like CSV files?
Similar. It's hard. It really is hard. Like, I mean, tabular data in itself, if you really have a lot of tabular data, LLMs/RAG is probably not the tool that you're looking for. Like, tabular data means structured data, so like if you want to ask questions about that, you're probably better off than in just reading, for example, in the CSV file, reading the header and giving the LLM like a specification saying, okay, this is what my data looks like, and then, for example, ask it, hey, write me some code that I can analyze this data with, and then just run the code yourself. This is probably the better pattern. So RAG is usually the best pattern in itself if you're working with unstructured data, text.
GPT vision is pretty good for example.
Yes? Yeah. I honestly haven't tried it yet, but like, this is also a point. But like then you have this whole, like the whole point of this talk is that you don't want to get locked in by OpenAI, so you will probably need to look for an open source model, and or look for a model that works on multiple vendors. Like, yes.
Yeah, so I'm guessing you're using Chroma on RAM. Basically, you don't
Yeah.
have the data as persistent. Do you have examples later where you basically persist the?
So my first nod was wrong. We're not using it on RAM. We're using it like persistent on disk, but it's not like one shared instance for everyone. But like for example, like Chroma has. I know that for a fact that Chroma has a hosted version where you can just host it on your in your data center and just connect to it. And so the way that would work is just you would put like you create your own source storage, call it whatever, hosted Chroma, hook it into Ragna, and then just everything works as before. But you have done one central. Yes.
Are you dealing with metadata from the PDF?
Currently, no. Not by default. We are in the process of adding something like that, but currently not. Yes.
I know Amazon has a model which can extract text from PDF. So will it work, for example, in combining of?
Sure. Yeah. So right now we are a little bit like it is a lot more. Let's call it grouped. Like we have the whole embedding and chunking pipeline inside the source storage, but we already have PRs up. It's not released yet, but like we have the code there to basically split it out. And then what you are basically saying is you have like this, let's call it this document handler. This is the term that we use inside Ragna. Like give it a document and give me output of the document is some text. If you have like your own custom thingy there, you can just put it in and go from there. That's the whole point of Ragna, to have this orchestration mechanism where it's like, okay, you can select the parts that you want. If you want to use this model, then go for it. Yes?
How do you control the trunk size here?
The what?
Trunk size.
Chunk size. Yeah. So Ragna internally currently has the chunking. Like I said, the chunking strategy is unfortunately currently fixed. We are building on like making it more flexible. Chunking is done on a token level, and so what you can do is here. I mean, we don't have it yet, but like it's in.
It's in, I think, number.
Oh yeah,
4
sorry.
Or something. I have the. Our notebook has it.
Yeah, shoot. I'm sorry. It's not my notebook. So, like for Ragna, this is currently the way to set the chunk size. Chunk size is based on tokens. Like I said, we're currently refactoring that. So I don't. Can we like? Is it important the question to have it now, or can we let Pavithra finish the notebook and then I am happy to answer questions at the end. Okay.
Cool. I think we were pretty much at the end of this notebook anyway, so it's fine. Yeah, we're just going to look at these sources used for this particular prompt. Just presented in a fancy way, that's all. What we're looking for is answer.sources, and answer is what we got here, right? So yeah, the sections of the PDF used to answer this prompt, that will be displayed to you. If you use that, I'm just going to minimize it. Okay. And the final thing is streaming. Because Ragna is async, we can stream answers pretty quickly. And what you do for that is set stream equals to when you do chat.answer, and that actually should just work. Yeah, so we are printing just for each chunk in your answer. Okay. And this is just one final prompt, not doing anything, but just because we wanted to add one more, that's all. But I'd let you, I guess, use the prompts that you want and see how this works. So that is the end of this notebook. So if you did have one more question, we can get to it right now. Okay, them first, yeah.
Yeah.
Here, I think let's just use this.
All the sources are not really related. Do you apply like a minimum threshold for loading the information into context, or do you just search for 10 most similar information and knowledge?
Yeah, right now we are going by number of tokens for the sources. So the splitting happens by the number of tokens. So for example, by default, we have like a token limit of 500 per chunk. And then at the end, we say, okay, like how many tokens do you want to put into the prompt? And say, like, for example, 4,000, then which means like we have like eight sources. What?
We can set that.
Yes, of course. You have
advanced config notebook, I think number 4.
Yeah. So we will have that in a later tutorial. But
presentation.
Sorry.
Yeah,
This one.
I think, yeah.
So there is something about the advanced configuration where you can basically set these parameters to whatever you like. Yeah, currently the behavior is hard-coded. With the next release, this will be much more flexible, and you can define your own scheme, basically. Yes, this question back there? Yeah?
Do you overlap document chunks?
Yes. Like if you see here, we have the chunk overlap. This is something that we realized was pretty significant because if you don't have overlap, you will very easily have chunks that are disjointed, and it's very hard for the LLM to reason. Like imagine you have like a paragraph about something, and this paragraph is just split into half. Like it's really hard for the LLM to reason about it if you have like this paragraph actually split up into 2 parts. And it's also hard for the embedding model to really capture the essence of the paragraph if you split it in half. So like this overlap is something that we experimented a lot with in the beginning. And like, again, I can't give you like really close numbers for your specific use case, but what we found is like just having roughly 30 to 50% overlap just gave us the best results. In terms of trade-off, like, of course, like more overlap will give you better results in the sense that the LLM has an easier time answering it, but like, this also means you have like a lot more vectors in your source story, like in your vector database, and it also makes it harder to find the relevant one. Like imagine if you have like 90% overlap and you ask a question and you basically will get 3 times or 4 times the same paragraph out of the vector database, because like if it's looking for one sentence or whatever, then this sentence appears in a lot of chunks. Okay, one more. Yeah, I'm sorry, I can't go by, I try to go by occurrence, so yeah.
So I just have a question because you said that there will be an update, or you will have a new release very soon, where it will have more flexible settings.
Yes.
Can you already foresee when that will be?
So you're asking me to give like a release schedule now?
No, just like more or less.
So we have a large PR up. It's still pending review because I needed to prep for this tutorial. But I'm hoping we can get this done in the next few weeks. There is more stuff that I want to change for the next release. Like, I'm happy to give you more of an in-depth answer after this talk. So what we're trying to have on the roadmap for the next release, but I don't want to say a date yet. Okay, next question back there. And then, sorry, let me, can we give the mic?
One. In terms of pump pipeline and chunk overlapping and vector databases, how graph databases fit in?
Could you repeat what you said after how what?
How graph databases fit in? When to use them, how to use them, why to use them?
I'm sorry. Could you repeat the question again? I'm still not getting the gist.
When you're talking about chunking and reg pipelines and data ingestions and creating vector databases, instead of using vector databases, when and why to use graph databases with LLMs?
That's exactly the reason why we didn't call the abstraction vector database in Ragna, but rather source storage, because we don't want to force you to use vector databases. In general, we're going to just implement the assistant, but the only two, let's call it features that any kind of database would need to have to work with Ragna is we give you a few documents and ask you to store the information about it. And later on, we are going to give you a prompt, and you give us back like relevant chunks of it. If whatever you have, graph database, whatever database you have, can implement this kind of interface, you can use it with RAG. We're just used to saying vector databases because that is the part of this whole, let's call it LLM craze. Like everyone is using vector database. Whether this is the right choice or the wrong choice, that is very much dependent on your use case. Like vector databases is a very easy choice because you have like, if you have embedding models, this is just very, very easy to set up. But in general, you can work with any kind of database that, like I said, that implements this interface.
Yes, I know, but in your experience, when you...
Oh, sorry. Oh, yeah. I don't have experience with graph databases, sorry, to answer that. Yes?
I have a proposal. Can we hold advanced questions until the end?
Sure.
Enough time to
yeah. Happy to, yeah. Cool, yeah.
I wanted to know, so when we use this RAG, right, with contextual data,
yeah.
So how does the LLM learn this new information? Is there a feedback loop on this RAG approach as well?
No, there's no feedback loop, but we will see how this works exactly in the next notebook. Yeah, let's do it. Okay, so the next notebook is about, we now know how to implement like a local LLM. We now know how to use Ragna. Let's use the two together. Okay, give me a second. So the abstraction class that we provide over LLMs in Ragna is called Assistant. And unlike the source storages, for the assistants, we only have like a single method that we need to implement. It's called the answer method. The answer method gets a prompt, which is a string, and it gets a list of sources. Sources is like an object that we define in Ragna, but like you can just, for this purpose here of this tutorial, you just can imagine it like a list of strings that we pulled out of our source storage. And we're just asking this assistant to provide like an answer, to take these two parts of information, combine them, and generate an answer from that. We have done it already here, and it's called in a file. It's called local LLM. I'm just going to expand it here for you guys to see. So what we have is this very we are subclassing from this assist. Oops, I keep pressing. That's not what I want. So we have this, our new assistant is subclassing from our base class, or abstract base class. We can define a few things that makes it easier for Ragna to work with, but we don't have to. So we have like a display name. You will see later on when we load this into UI, we actually have like a human readable name for it. We have some requirements, like Ragna is automatically going to check if these requirements are available before it actually starts to load this kind of stuff. In our case, we just have 2 packages that we want to load. Yeah, we also want that CUDA is available when we load this. So this is like the backend or the accelerator backend, so we can actually run this on the GPU. Yeah, then in the constructor for class, we're just going to load exactly the same code that we had before. One thing that I touched on earlier here is the temperature. So like for RAG, usually you want to have determinism. You want the LLM to always answer exactly the same that you, whenever you do like a run a second time. So this is why we usually, or you will see like the temperature is always set to 0, so no sampling is going on. And yeah, then I'm going to skip this because we're going to talk about this in a second. Then we have the answer method. So the answer method in Ragna, you should probably also be already familiar with the code because we had it earlier. It's just this generator starting the stream, looping over the number of tokens that we want to generate and just yielding back the results, and yielding because we want to have streaming. The interesting part is here, we have our tokenizer, and this tokenizer encodes not our prompt directly, but something that we call make prompt. And this is basically where the, let's call it the magic of RAG happens. This looks very complicated. It is complicated to write, it's not hard to understand. What happens here is RAG, the whole pattern in RAG works like instead of just sending the LLM your prompt, you're taking the sources and put them in the prompt together with the prompt that the user has. So like, let's call it, you have a user prompt, you have sources, and you have then the prompt that you're actually going to send to the LLM. It's just basically like a string concatenation of these two, including some instructions. So what you see here, for example, is answer the question based on only the following context. This is usually what you refer to in another system prompt. You can put in more stuff in there. So like you often have like you are an honest assistant. Do not answer like with anything. Like do not make up information. Whatever. This is something that you can customize to your need. Like this is basically trying to tell the LLM how it should behave. And the important word here is trying, because this is just instruction that you gave it. Whether or not it's going to follow it, it's like a total different story. So this is the whole, let's call it discipline. I'm not sure if it's a discipline. It's more like an art form. It's called prompt engineering, where it's like phrase the prompt in a way that the LLM is actually doing what you want it to do. And this is very much dependent on what kind of LLM you have. And like, for example, if you use ChatGPT, like whenever they do an update, you would probably have to redo all your prompt engineering or prompt processing because, well, potentially, which is also like a good idea to have this stuff running on your own hardware, because then you control updates. Like we had a project where a client was super happy with what we provided, and one day to another they said like, oh, this whole system doesn't work anymore, and we tried to figure out what happened, and yeah, like an OpenAI update happened, and so questions that worked before didn't work afterwards anymore, and there was nothing that we could do other than saying like, okay, you guys, like if you want to have it this way, you're locked into OpenAI, you're basically under their thumb. Like if they change something, there's nothing we can do. You should probably look into solutions to host this stuff yourself. Yeah, so you see a lot of these special tokens here. This is like these HTML tags with these vertical bars in there. Like every model has their own template on how you need to format this. This is usually in the, like, I'm not going to try to go to Hugging Face again, but like you see in the model card, there's usually an explanation and what form this model expects the prompt to be. And you just follow it, you program it once, and you never touch it again. So this is kind of like I said, it's hard to write because you need to be very specific. Like the models are usually very specific about this kind of formats, and if you have it once, then you don't need to touch it again. And they are very picky about these formats because like if you've seen this kind of format 1 billion times already, you expect it to be in exactly this format the 1,000,000,001th time if you give it a new prompt. So this is why just basically copy and paste this exactly like they have it on the model card and then go from there. Yeah, and like the only thing that you see in here that is interesting for us is we're just going to list the source content here, and we're going to have our prompt in there, and that's it. The rest around it is just the way that this model, Llama 3, expects the prompt to be. And I already also put it down here, like apart from this make prompt function, this assistant that we provide is actually like an XLlama 2 assistant. You can basically plug in any model. It's like this thing is model agnostic, except for the make prompt function. Like the make prompt is what you would need to change on a per model basis because like each model expects something different. Like, so this thing is actually called Llama 3 instruct, but you could basically use it for other models if you change this one function. Okay. So we're just going to import this one here. We're going to see the display name. Display name is this one here. TurboDerp is the one who quantized this model for us. This is also the maintainer of the XLlama 2 library. We can check if this is available, and I hope this goes through, because if not, we're going to have a problem and can't run it, but like it should be. Yes, perfect. It takes so long, but it actually checks if all the libraries are importable and stuff like that. Okay, and from here on, we can use basically the same pattern that we saw in our last notebook. We're just going to provide a few documents. We're going to start a chat, and instead of using like the built-in GPT 3.5 or GPT 4 that we have, we are now using the one that we have just implemented. And now we can do exactly the thing that we have done before. Let's prepare it. Like Pavithra told earlier, this prepare step is like embedding the documents into our vector database. So this can take some time. We have, by default, a fairly small embedding model that can run on CPU, but of course you can use either like a large one running on a GPU as well, or you can use like OpenAI, for example, also has like embedding models like as an API. You can use them. That's totally up to you. Yeah, and so the prompt, I mean, I can't show it you in full detail, but here's I'm going to read it. Who is the Python developer in residence? And we're giving it the annual reports of the Python Software Foundation. Let's see if the model can handle this. If someone is familiar with the PSF, the answer is actually correct. So I'm not going to show you the sources. Of course, you can take the message again. You see the sources that were pulled out. You can verify that this information is actually correct, which is, we haven't really, I'm not going to talk a lot about this, but this is one thing that is really important to make RAG useful for in a production setting. You cannot really trust an LLM to do the right thing. So you will always need to have an option to verify that the information is correct. And Ragna makes it sure that you always get the sources listed along with your answer for you to have a way to say, okay, where is it actually pulling these numbers from? Like numbers is especially one thing where it really goes off the rails really easily. You will see it in the next notebook that happens quite easily. Yes, please.
How would it deal with contradicting information in documents?
That's basically the answer. It's like it really depends on an LLM. Like I've recently seen videos where you can someone tried to gaslight GPT or ChatGPT into answering 2 + 2 = 5, and you just prompt it over and over again, and at some point it just gives up and she says, okay, if you say so, 2 + 2 = 5. Okay, I'm just going to roll with that now. And so in the end, like what you really need to remember is this thing doesn't think in any capacity. It's just a way of like generating token after token. So at some point, like if it thinks that the next best token is just something that contradicts, for example, what it said earlier or whatever, and it's just going to output that. This is why I've talked about the sources. Like, it's really important for you to have a way to actually look into that. Like, if you see talks about this is one thing that is really important with all these RAG pipelines. If you build them, you need to have trust in the way that this LLM is actually answering stuff. And like giving the user a list of sources that were used for where they can actually verify that the information that was sourced is a very good way to do that. But there will never be like 100% accuracy or whatever. Yes?
As far as I understand, when you call chat.answer, it actually creates a prompt and fits all this relevant information in the prompt. Is there a way to debug it and see the full prompt that was fed in the model using Ragna? Sure.
I mean, we have it, like, if you open your local LLM thingy, instead of just returning here, just print here. Or, like what level of debugging are you looking for?
I just want to see the full prompt.
Yeah, happy. Like, this is, you have these files on your Nebari instance. Just go ahead and hack at them and try to see what's happening. So the source code for this is actually in this local LLM file. 10 minutes left for this or in general? Oh, shoot. Okay. So then let's quickly come, like, the questions that are still open. Can we move them at the end so we can at least show, like, a little bit of the last notebook? Cool. And I'll let you have it.
All right. So just stopping the kernel here, and we can go to the last notebook, which is doing everything we just did, but with the UI. So here, there are a few steps you need to follow, so try to, I guess, do it along with me. First off, in the file explorer, you should see a ragna.toml.template file, right? Yeah, so copy over all of this into a new file called ragna.toml. So we need to do all of this only because we are running Ragna on Nebari right now. like on Jupyter Hub, so we need to do some proxying to make this work correctly. On your local machine, you should just be able to run Ragna UI, and it should work as expected. Yeah. All right, so copied it over to a new file. And then if you look at API root path and URL, right? So under API, this is TOML, so API, root path, and URL. There is a user field. Just make sure you have your username, like the one you use to log into Nibari. It should also be available like in your URL itself, like your browser URL. Okay, so there are just two fields you need to change, which is root path and URL, and save this file. Is that clear?
Also the URL.
In a, okay. All right, so just repeating the steps. There is a ragna.toml.template file that all of you should have, right? Yeah. So copy the contents over into a ragna.toml file. This is a template that everyone has that's similar. Yeah. In your local one, which is ragna.toml, just update the user with your Nibari username. So that is the one you got from the spreadsheet, right? And if you forgot what username you had, it should be visible in the Nibari URL at your browser level after user. So mine is this. Does that make sense?
Should we also do Quansight.com or just the name?
Oh, no. My username is the entire thing. So this, okay, right. Yeah. Okay, so just save this file, and then we should be good to go. All right, so let's open a terminal window. So this is Jupyter Lab. You should see a terminal at the very bottom of this launcher. I'm just going to move it to a separate side, so we have these together. So two things. First is just activating the environment. We've been using the global PyCon DE. So copy that over to activate the Conda environment, and sharing this file to Ragna UI. That's what this is doing. This is a little bit of like patching script that's running Ragna.ui at the Nibari proxy that we needed to run it on for folks. Right. Once that is running, right. Okay, this is going to take a little bit longer. This is because we forgot to change from Mistral to Llama in our TOML. So in your Ragna.toml, okay, I'll actually take a step back. So this file is how we configure Ragna itself, because Ragna is an orchestrator. There are a lot of things you can configure. And this wasn't really necessary for the Python UI, but when you use the REST API, the config file is where all the information is pulled from. So if you see, we have source storages, we have assistants, list of things here. So when you use the REST API, these are the ones that will be available. So here we have Mistral. We will need to change that to Llama. Yeah, I mean, it didn't work. Yeah. Oh, it's updated for you? Yeah. Okay. Cool. But yeah, I thought we pulled right before. Okay. I will change it though. What was it called again? Oh my God, this zoom level is hard to work with. Okay, that's the one. And I will change it. Okay, so now it should work for me as well. Once this starts up, you should see some notes from, notes about just server starting up and such, and then go to this link. Again, just because this is, all of you have a separate instance, you need to change the user field here to your Nibari username. And yeah, if you go to this URL, the Ragna UI should be up and running. Did mine work? I need to change that. Oh, I'm seeing an insufficient VRAM. Again. I'm going to restart this one.
Yeah.
Yeah.
What I've seen a few times is if you just click the stop kernel in a notebook, it's not actually shutting down. If you see in the file explorer, next to your notebook, if there is a green dot, it means this kernel is still running. right-click the notebook and just do like there's a shutdown kernel. And if you click that, you have to wait for a few seconds. If the green dot disappears, then the kernel is actually shut down correctly. So you need to have that before you can move on.
Oh, I had it open as well. Okay. Okay. Let's resize this. Right. Third time's the charm. Yeah. Anyway, so if this is running for y'all, yeah, you should just be able to go to the corresponding URL. Well, we can take questions, actually, while we wait for this to spin up. Oh, there you go. It started. All right. And now, oh. Looks like, there you go. All right. Yeah, so that's what the UI looks like. I think this will be blank for you. Like, you won't have any past chats. This is the things we had. So, yeah, the UI, this is something Ragna ships with. And locally, as I said, it's Ragna UI to run it. And we can start a new chat from the UI and select the list of assistants. So we had OpenAI previously, and we had Llama 3 that we worked on just now, and pick a storage. So the demo assistant and demo storage you see here, they are not actually doing anything. They're just presenting the same thing in the right format. That's all. Like, it's just for you to make sure, for us to make sure that Ragna is working correctly on a computer. Like, it's not an external issue. So those are not like actual LLMs or actual databases. Those are just going to print the same prompt, if I remember correctly. The Ragna demo assistant, that'll just print the prompt back, right? Yeah, it's not actually. So we'll use something else. So let's use our local one. And we can give it some files. Oh, okay. So there should be files on Nibari, like in the files folder, right? You can probably download them locally and add it here. I think I just downloaded the PSF annual report that I will drop. All right, and start a conversation. We're at time? Huh? That's time, right? Okay, we are at time. So I guess just to complete this, the UI. So ask any question. Should I ask a question? Okay. Okay. Oh, okay. So you want to do that?
Yeah. So please, Levs, that was an awesome workshop. Help me with giving a huge amount of applause to those two. And we are over time for a coffee break in case someone is hungry, but they will be in the room for more about 10 minutes. And then after that, we have another workshop. So thank you very much.
Thank you.